The Russian army spent months laying mines and traps in critical areas and passageways. But Ukraine used unimaginable tactics to blow Putin's traps up in his face. Using the enemy's traps against them required great coordination, intelligence, and tactical awareness. In this context, on August 2nd, Ukrainian forces carried out a demolition operation that looked like something out of a military thriller. The incident was highly dramatic for the Russian army. This is because the Russians had placed TM-62 anti-tank mines on the bridge over the Tsata River. They had prepared to blow up the bridge in the event of a Ukrainian attack in the Bryansk region. They hung nets and set traps to protect the bridge, and in the event of a possible Ukrainian ambush, the Russians would press the button as Ukrainian troops crossed the bridge. But moments later, a Ukrainian FPV drone pilot, using a fiber optic connection, skillfully overcame all obstacles, accurately hit the Russian mines, and blew up the bridge. The strike asset selected for the bridge in Bryansk was a carbon fiber-bodied, FPV-controlled 3 to 4 kilograms class kamikaze drone. The 400 to 500 grams of explosive material placed in the front section of the body was insufficient to detonate directly. Nearly 30 TM-62 anti-tank mines were placed under the bridge to block Ukrainian advances. These Soviet-made mines, with steel bodies carrying 7 to 8 kilograms of TNT, had the power to shatter a tank's underside. Under normal circumstances, these mines would be activated either by a mechanical trigger system or by remote detonation. But this time, Ukraine started the chain reaction. However, when it struck with precision, it was powerful enough to create a shockwave that would trigger one of the TM-62 anti-tank mines inside the steel console holding the bridge. The TM-62 contains 7 to 8 kilograms of TNT in its body, and the pressure exerted on its fusion element triggers the mine. The chain reaction anticipated by the Ukrainian planners began precisely here. When a single mine detonated, all the other mines embedded in the bridge's structure exploded one after another. In total, an energy equivalent to nearly 250 kilograms of TNT was released. The concrete pavement layer, along with the steel beams, was lifted several meters into the air before shattering and scattering into the Tsata River and its surroundings. According to eyewitness accounts, an area with a radius of 100 meters was nearly completely transformed into craters and debris after the explosion. In footage shared on social media, the FPV drone can be clearly seen gliding at low altitude, then locking onto its target and colliding with its support leg, followed by the start of a destructive chain reaction explosion a few seconds later. With the explosion, the drone camera goes dark, and then a column of flames rising into the sky is reflected in the camera. As a thick layer of smoke rises in the area, only charred metal pieces and blackened concrete blocks remain of the bridge. With the collapse of the bridge, evacuation and support links for Russian troops stationed along a 16-kilometer border strip have been completely cut. The explosion destroyed not only a passageway, but also Russia's confidence in its border defense line. But don't think that an ordinary target was destroyed. This was a Russian defense hub that had been carefully prepared not only from an engineering standpoint, but also on a tactical level. The basis of this operation is Ukraine's drone doctrine, which has been maturing in the field. Kiev has abandoned its Soviet-era heavy industry-based defense concept and perfected the low-cost, high-impact formula with cheap, agile, and smart platforms. According to OSINT sources close to the Ukrainian Ministry of Defense, the troops serving in this region are currently effectively trapped behind Ukraine's front lines. So why did Russia set such a trap for itself? The reflex to protect the border was based on the buffer corridor doctrine, officially announced by Moscow in the fall of 2023. Under this doctrine, a series of fixed defense lines were built along the Bryansk, Belgorod, and Kursk regions. The main goal was to stop possible Ukrainian ground attacks before they reached the border and to create a defensive depth within Russian territory. To this end, anti-tank trenches were dug for miles, minefields were laid, concrete blocks were used to create barriers, and remote-controlled explosive devices were placed under strategic bridges. But this defensive architecture also had a weakness. The geographical structure of the region was extremely limited in terms of alternative passages and logistical flexibility. Concrete bridges built over natural obstacles, such as the Tsata River, served not only a tactical, but also a strategic lifeline function. These bridges were indispensable, not only for the passage of military convoys, but also for the advance of armored units, the transport of ammunition and fuel, evacuation routes, and even basic lines to rear logistics centers. The bridge over the Tsata was an absolute choke point due to the inadequacy of the surrounding infrastructure. The dirt roads to the south were muddy during the summer months due to sudden rains, making it impossible for heavy transport vehicles to pass. The forest cover to the north consisted of narrow, sloping slopes, unsuitable for armored vehicles. Therefore, the destruction of the Tsata Bridge eliminated not only a transport line, but also the main supply and evacuation corridor for all Russian forces in the region. How Ukraine achieved this cannot be explained by simply flying a drone. First came the intelligence step. Both satellite imagery and frontline intelligence sources were used to map the mine configuration in the area. Civilian-looking, fixed-wing surveillance drones recorded military traffic between the bridge's entrance and exit for a week. Video analytics revealed the times when fuel tankers and armored personnel carriers passed through. Heat map analysis identified the traces of excavation activities carried out by Russian excavators at the bridge's foundation, which helped determine the timing of mine laying. Signal intelligence then came into play, since Russian engineering units used low-power RF firing modules to remotely trigger TM62 mines. Electromagnetic interference patterns were observed in the area. Interference windows confirmed the geographical distribution of the mine array. The final attack plan was drawn up, assuming that there were 3 main drive points on the northwestern leg of the bridge and 1 on the southeastern leg. The target was the corner leg, where at least 2 mines would trigger each other. The FPV drone, equipped with a limited explosive charge, locked onto this leg. The drone's final maneuver, lasting 10 seconds, was designed to move parallel to the ground and then suddenly climb upward, causing the body to strike the underside of the bridge girder. One important detail to note is that the bridge has been designated a red zone by Russian troops since the first year of the war. There are unmanned surveillance towers and thermal cameras, but most of the night vision algorithms are focused on tracking trucks and vehicles that give off high heat signatures. With its composite carbon body, electric motor, and minimal IR signature, the FPV drone was almost impossible to detect on Russian surveillance screens. When the flight speed reached 120 kilometers an hour, the detection window dropped to 2 or 3 seconds. A very short window for a human operator to react, activate an RF jammer, or relay orders to a drone defense artillery unit. When considering why Russia couldn't prevent this, 3 answers emerge. First, the mine network laid under the bridge falls under the passive defense category. While the mine is under the bridge, the RF trigger cannot be jammed with interference because the activation sensor is triggered by mechanical vibration when the drone collides with it. Second, Russian electronic warfare capabilities were weak near the bridge. EW teams were deployed deeper into the front lines to protect critical radar domes in Belgorod and Kursk. This rural area of Bryansk was primarily a transit point for ground convoys. Air defense was a low priority. Third, the Russian army adopted a modular corridor approach instead of a comprehensive surveillance network, so sensor data does not flow to a simultaneous command center. Each bridge is under the responsibility of a separate unit. Different regiments carry different EW codes. In such fragmented networks, opening a window for rapid reaction is nearly impossible. Looking at the impact of the attack on the front lines, logistical delays are already being felt. Russia was moving an average of 300 tons of fuel and ammunition per day through Bryansk before the bridge was destroyed. In the first 48 hours after the explosion, shipments fell to almost zero. Alternative routes offer 2 different bypasses, via Klintsy in the north and around Starodub in the south. But both routes are longer and have been marked as sensitive areas since previous Ukrainian drone attacks. The first figures included in ISW's daily frontline report indicate that approximately 5 Russian units have shifted positions along the Bryansk border under the pretext of a tactical withdrawal. In reality, this is not a withdrawal, but an inability to hold positions due to supply shortages. If the fuel convoy cannot arrive, the 6 soldiers inside the BMP-3 cannot maintain the fire support line. When ammunition trucks are delayed, it becomes impossible to defend 122mm artillery positions with AK-74 rifle fire. The psychological impact is even more intense. Russia frequently uses the concept of a deep rear in its propaganda. Regions close to Moscow, key bridges behind the front lines, and major railway junctions are claimed to be under absolute protection, out of reach of Ukrainian drones. The destruction of bridges has undermined this claim. Images shared on Russian social media by relatives of soldiers show not only bridge debris but also armored convoys diverted onto side roads. The question, "Why are our mines exploding on us?" has been trending on social media. The economic impact extends beyond Bryansk. The bridges in the border region are the arteries of the north-south logistics axis stretching from the Caucasus to St. Petersburg. When this route is cut off, additional strain is placed on railway traffic between Rostov and Donbass. Railway transportation accounts for 70% of Russia's total military logistics. The destruction of a bridge may seem like a minor setback at the macro level, but if we consider the series of events that took place at the same time, with oil depots burning in Sochi, a tanker station being hit in Volgograd, and a fuel train exploding on the Rostov-Salsk line, the cost multiplier grows. While the cost per UAV ranges from $5,000 to $25,000, repairing a concrete bridge can cost $4 million to $5 million. When multiplied by fuel supply delays and armored repair bills, the damage adds up to a staggering figure. The attack also stands out as a textbook example of Kiev's deep strike logistics disruption strategy. This strategy is based on a 3-tiered attack architecture. The first layer consists of low-cost but high-impact continuous drone attacks. FPV and fixed-wing kamikaze UAVs are sent in waves to targets behind the front lines. These attacks are often carried out with decoy UAVs to confuse air defenses and force them to overreact. As a result, the Russian defense system becomes unable to distinguish which threats are real. The second layer is the precision strike phase, where high-precision guided munitions come into play. Western systems such as JDAM-ER, Storm Shadow, and Scalp-EG target critical infrastructure such as radar towers, fuel tanks, bridges, and command centers. The third layer consists of electronic warfare-supported signal jamming operations. Jamming systems such as Nemesis, Bukovel, and Thor in Ukraine's inventory blind the radars of Russian surface-to-air missile batteries, facilitating the previous 2 layers' targets. This 3-tiered structure was applied exactly in the attack on the bridge over the Tsata River in Bryansk. Electronic warfare assets near the Ukrainian border prevented Russian EW units from tracking the drone's routes and taking countermeasures. The FPV drone then targeted Russian anti-tank mines placed directly on the bridge's support columns. The force of the explosion came from both the munitions and the chain reaction. The invisible aspect of the operation is the drone technology itself. Several Ukrainian startup companies have produced semi-artificial intelligence control software for FPV drones. The operator manually flies the drone until the final approach. In the last 15 meters, the internal LiDAR and optical matching systems kick in. The artificial neural network identifies the weakest point of the bridge's structure and sends a confirmation signal to the pilot. This minimizes factors such as signal delay and wind drift. No matter how small the target, the drone hits its final point, known as the laser, with millimeter precision. In Russian defense doctrine, countering this is only possible with hard-kill cannons or high-energy lasers. However, Russia's Pantsir S-1 batteries experience delays when firing 30mm cannon shells even if they detect a 1kg FPV drone, and if the detection-to-fire window is less than 2 seconds, the artillery response cannot keep up. High-energy lasers are still in the prototype stage. This technological asymmetry is directly reflected in Putin's image. The most critical component of the military modernization narrative that the Kremlin has been building for years is air defense. Platforms such as the S-400 Triumph, Pantsir, Tor M2 and Baikal radar were lined up like decorations in parades. Now, images of FPV drones costing a few $1,000s slipping through the S-400's blind spot and disrupting Russia's own mine system are undermining the triumph narrative on the ground. What is devastating for the Russian public is not so much the magnitude of the loss as the fact that the trap has backfired on its creator. The long-term equation that will result from the bridge destruction may force Russia to question its mine trench defense doctrine. When combined with the bridge, the mine protecting the shelter becomes a potential bomb ready to explode. Moscow will either reduce the number of mines. This will open the way for Ukrainian ground forces, or else a bridge system with more steel-plated mines will be needed, which will increase costs and extend construction time. The rule of military engineering that protection, if it lacks flexibility, backfires, is being added as a footnote to Russia's Bryansk lesson. Finally, we must address Putin's political image. A regime that bases its legitimacy on the strategic control myth must rewrite its narrative when it loses a bridge due to its own mine plan. Let's end with a pertinent question. If the Kremlin's mine explodes on the border bridge, who will defend the watchtowers in Moscow? Public perception is embracing the narrative of disaster rather than explaining the failure. Russian history is familiar with the smell of gunpowder from military mistakes, from the Afghanistan trauma to the Chechnya fiasco. But this time, the mistake is not exploding on the front lines, but in the backyard. The smell of gunpowder at home is too strong to be suppressed by any propaganda. The destroyed bridge in Bryansk is not just a pile of concrete and steel. It is a living monument to the defeat of a costly legacy of defense by a wave of cheap and clever attacks in the old-new war equation. Ukraine made Russia pay for this with an FPV drone. Russia fell into the trap it had set by laying mines. The war will continue, but now everyone knows that the side that can bomb the red lines on the map, not on the battlefield, will win the game. Thank you for watching.